Oops, I didn't record the lesson, so it's going to be a bummer for people that missed the class today. But I'll start recording it now. Okay, that's the idea for this first example here. Okay. This next part, this is kind of our long part for today. I found there was an investigation in the book that I really liked. So it's on page 278 if you want to look at it in your textbook. I split it up here. It's kind of a big investigation. So actually, sorry, it starts on page 277 even. So in this investigation, you will see that the line of best fit drawn by I through the mean point can be improved. So what do you think improved means in this context, or improved means? Okay. And just basically the idea is we should be able to quantitatively calculate a line of best fit that's going to do better than just eyeballing it. That's the idea. Okay. And the way we're going to do that is we're going to use something called residuals. Okay. And let's go ahead and talk about residuals real quick here. A residual is the difference between the actual y value and the predicted y value. All right. So, so what that means really is, if I'm looking at this up here, I can see the red dots are the actual points. And let's use the green line right now. Right there, that distance right there is my residual. It's the difference between where the actual point is and where the point should theoretically hit the green line. That's where the residual is. So we can see another one right there, see another one right there. It can be below the line. That's what residuals are. Some of them have very small distance to the line. Some of them have to go pretty far to get back to the line. All right. All right, so what I'm going to ask you guys to do, this is going to take a few minutes, but we're going to look at these two lines. There's the green line and the blue dash line, and we have two different equations for them. So I'm going to say, here's the green line, highlighting the equation. Line 1, y equals 0.81x plus 2.36. The blue line, line 2, y equals 0.65 plus 3.08. And what we're going to do is we're going to calculate some values down here. So first we have the points from the data set. They're listed on the left-hand side here. Okay, there's the points listed. I'm just going to go ahead and copy the y values down. 5, 3, 7, 5, 9, 7, 9. Now, this shows the calculation here, but it's a little tricky to follow, so I'm going to help you out a little bit here. So the first one, predicted using line 1. So this is going to be green here. And then predicted using line 2. That's going to be the blue line. Okay. So what we're doing is we're taking the equation from up above, and we're going to plug in the x value of the equation, and we're going to solve for y. So this one would be so I'll do it in green for consistency. 0.81 times 2, and that 2 is right there, the x value. All right. Plus 2.36. and then we'll get a corresponding y value. And then to find the residual, we're going to need to take 5 minus whatever that answer is, and that's going to get us our residual using line 1. Okay, so that's where the 5 comes into play, is from right. I'm going to do the 5 in yellow. So that's where the 5's coming into play there. All right, so I want you guys to work on this table. I'm going to zoom in on my screen so I can actually fit everything in on the line, and I'll fill it in as well. But it'll take you a couple minutes to work on this table, but go ahead and get it going. All right, so we get this data filled out. You guys might still be working on it a little bit. There was a lot. Okay, a lot of points to go through there. But the idea is, what we're going to do is we're going to create something called a line of least square regression. Okay, so to find the two lines, we're going to do the sum of the squares of the residuals, and that's what the next table is going to be all about. There is a little typo on this table, just so you are aware. You don't need to do anything in this column here. You're going to do the summation, in this column. So remember, that's your sigma, that's our summation notation. All right, and we're going to do sigma of the square of the residuals. So basically, you're going to take your answers from the previous column and you're going to copy them down from the residual line up above. So right here, all of these values are going to go in this row. And then all of these values are going to go in this row. Okay. And then you're going to square each individual value. So like negative 0.17 squared is 0.0289. Okay. So go ahead and let's get this table filled up. And then at the end, you're just going to basically add all this row together to get the summation. Okay. That's the goal here. Okay, so let's fill this table in. Okay, so to get the square residuals again, we just literally squared the value. So just took that 1.02 and squared it to get the 1.0404. And then we just added all of these values all the way down to arrive at our sum. Down here, 11.4164. And then for, yes, question.
Residual using 1.1 for data 7,7 is supposed to be negative 1.03.
Negative 1.03? Did I mess it up? Oh yeah, you're right. I used 7 instead of 8. That'll change all of my values. See, so thank you for catching that. Okay, so this should be a 7, and that makes it a negative 1.03, and then negative 1.03. What was the negative 1.03 squared when we do that? Who's got that value? Since I had the wrong one. So it should be 1.0609. So 11.4164. Okay. So should my residual value then be, it should be 12 something. Let's fix that. Thank you for catching my mistake. So do we get 12.4764? Does that look better? I'm hoping. I might still be off, but if I'm still off, let me know. So look at you guys on top of it. I'm looking at the chat now. Yeah, you guys crushed it. Way to catch that mistake. Okay, good. You're paying attention. I like it. All right, so is this the right value, though, for the sigma, or did I still mess that up somehow? I can recalculate it. Just want to make sure. .2041 plus 1.96 plus 9881 plus 3.1684. So I got, oh, it looks like it should be 12.4456, so I'm a little off again. Okay. So do we get this number instead?
I got 12.4475.
4475. Okay, so still a little bit off. How do my numbers match up to yours here? Are there any others that are off? I might just be adding it up wrong. Oh, I didn't add the 0.289 at the very top. Duh. That's what I need to do. 0.289. I forgot about the one in the black at the very top. Plus 1.96 plus 3.1684 plus 0.0256. 12.4693. And that's kind of where I'm at now. I could still be off, but hopefully not. I just went through that really fast. I thought I had my numbers right this morning, and I totally missed one. But that's where I'm at right now, the 12.4693. But the idea is we're getting somewhere in the 12s. Hopefully I didn't mess that one up. For the blue one, I'm going to write that one down. I had 13.5452. I could have messed that one up too, you never know. Can anyone verify my number for the second one?
That's what I got.
Perfect, that's what I like to hear. And how about the first one? Anyone verify the first one, or am I still off on that one? Go ahead and type your number for the first one into the chat, and we'll see if we have a lot of people with the same number or not. Yeah, there's a lot to go through here on these problems, a lot of numbers to cut through. So, Anyway, the big thing with these ones though, let's see what we got for the first one. 12.4764, 4764. See, look at you guys. You all have 4764. So you all have the same number, different than mine. Mine, which is off. So let's go ahead and fix that then. Okay. So you guys all have 12.4764. And hopefully that includes this value as well, because I forgot to include that value when I was doing my first calculation. Okay. .96 plus 1.9881 plus 3.1684 plus 1.0609 plus 0.0256 plus 0.0289. 4764. All right, we're gonna go with that for the 12. All right, perfect. So, moral of the story: one of the summations is in the 12 area, one of them's in the 13 area. So what we're looking for the smallest possible value of the sum. That's the key here. Smallest possible value of the sum of the squares of the residuals. So that's going to be the 12.4764. So that means the line we want to use is 0.081 x plus 2.36 y equals. That's the more efficient line for the line of best fit here for this problem. That's kind of the idea with this squares of residuals thing. So what estimate would you give for when y when x equals 1.5? Well, now you would just literally, you can plug in 1.5 into this equation for x and solve for y. Once you have the equation, that's the useful thing about it, we can plug in and solve for it. And we're going to get a y value of 3.575, so that'd be a good y value there. So that's where the important thing comes in here at the very end when it's asking, how do you find these y values? You're just going to use the equation and say, this should be where the y value is. It should be on this line. Okay. Okay, let's moving on. I keep zooming in. I want to zoom out. There we go. Okay. So the least squares regression line is the line of best fit that has the smallest possible value for the sum of squares of the residuals, which we just said. All right. If x is the independent variable and y is the dependent variable, then the least squares regression line is also called the regression line of y of x. And that's honestly what you're going to see it called in your textbook, is the regression line of y on x. And that might be what you see it called on an IB exam as well. All right. And then there's this formula. This is how you find the regression line of y on x. Okay. And we'll break it down right here on example 4. Just for the set of the data points here, we got 3 data points. Find the regression line of y on x by using this formula. So the first thing you're going to really want to do, if you want to be able to do this successfully, I would say let's go ahead and look at this formula. There's a lot going on. There's some things I recognize right off the bat. I see a y mean and an x mean. And then there's this weird s of x, y in there, which does it's like the sum of x times y minus the sum of x times the sum of y all over n. And then there's this s of x sub squared, which is like the sum of x squared minus the sum of x squared over n. It's like all this weird stuff going on. So let's break it down a little bit here with our information. Start by creating a table. And I'm going to create an x column, a y column, there needs to be an xy, and then there needs to be an x squared, because we have an x squared as well. And on the table, I'm just going to put the points in. Hey, there's 1 and 2. There was another one that was 3 and 4. And there's another one that was 5 and 3. Okay. Well, xy is just x times y. 1 times 2 is 2. I'm going to do a different color here. Oops. I can make this a little better for us. All right, so different color. 1 and 2, 1 times 2 is 2. 3 and 4, 3 times 4 is 12. 5 and 3, 5 times 3 is 15. And then x squared, 1, 9, 25. That's where these numbers come from. Now, what we could do at the bottom here is we could say, hey, let's do the sum of x, which is 1 plus 3 plus 5, 9. Let's do the sum of y, which is 2 plus 4 plus 3. 2 plus 4 plus 3, 6 plus 3, also 9. And then we do the sum of x times y. 2 plus 12 is 14. Plus 15 is 29, and the sum of x squared. 25 plus 9 is 34, plus 1 is 35. So we come up with all these values, and what happens now is we have the sum of x, that's going to be right here. The sum of y, right there. We need to know the sum of xy, that's going to be right here. We need to know the sum of x squared, that's going to be right here. Okay, and then we also need the sum of x again, I guess, the sum of x and then squared. But that's what all these values are here. So we need to find those values. It's kind of a weird way to think about it, but that's what we're going to do here. Let me go ahead and use a blue pen here. We'll say sum of xy equals the sum of xy squared, 29, minus the sum of x, 9, times the sum of y, 9, over n. N is the number of data points. In this case, n equals 3. Okay, so this is how we'd find this weird s of xy thing. We would get 81 divided by 3. All right, and that's 27, and we get 29 minus 27, and that's 2. That's how we get this value. The other weird value here was the lowercase s squared, and we say that's the sum of x squared, 35, minus the sum of x squared all over n, which is 3. So again, we get 81 divided by 3 is 27. 35 minus 27 equals 8. So we've come up with those two numbers, and that's where 8 is going to go here in that equation, and 27 is going to go in that weird equation. And then the only other thing we need is we need to know what the means are for these values. So find the mean of x and the mean of y. So we already know the sum of x is 9 and the sum of y is 9. So if we just do 9 divided by the number of data points, 3, we would find our mean of x. So mean of x equals 3, the mean of y equals 3. And again, that's just finding the mean. You can put it in your calculator or something. And now the very last step to finding your equation line of regression. This is really weird. I know it's a weird formula thing that we're doing here. I'm going to do this in red. We have y minus, or y mean 3 equals SXY was 2 over 8 times x minus our x mean. Our x mean was 3. And then we end up with 2/8 is going to simplify to 1/4. X minus 3. And then we can say 1/4 x minus 3/4. And then we add 3 to both sides. And 3 is going to be 12/4. So minus 3/4 plus 12/4. And we end up getting 1/4 x plus 9/4. And all that work gets us to this final equation here. It's a lot of work. But good news is I'm never going to ask you to do that work again. Last example, example 5. Oh, come on. All right. At a coach station, the maximum temperature in degrees Celsius and the number of bottles of water sold were recorded over 10 consecutive days. The collected data is summarized in the table. All right. So we would just want to take our x values and our y values. We're going to plot this scattergram, and then we're going to comment on the correlation. We're going to find the equation of the regression line. So that's where we're going to need to put this in our calculator to do that. So this is where we can do the calculator practice. And then we're going to draw the line on our graph. Okay, so let's go ahead and plot the data points and get it in your calculator. Okay. So you're going to go stat and get to your calculation, your edit, list 1. Once the points are plotted, I would say positive correlation. And then strong, moderate, I'm not sure. If I'm not sure, then I can run my my Pearson test that we talked about on Tuesday. You just plug that into like an Excel spreadsheet, or you can do that on your calculator and figure out the Pearson coefficient to prove that it's strong or moderate. Something like that. I'm guessing kind of strong. It looks pretty good. That I can draw a nice line through there. Okay, and then I find the equation of the regression line. I want to plug that into my calculator and then follow that stat plot thing and the 2 variable stats thing that they talked about in there in order to find that equation. Okay. And once you do that equation, you guys should come up with something here. I'm going to do this in blue. Y equals 8.05x minus 24.7. And once you have the actual equation, you know what the slope's going to be. Like every number you're going over, you're going up 8.05. And then the 24.7. So the line's going to start, let's see. It's going to start like somewhere over here and cruise through. Oh, come on, that's brutal. All right, and then go through our data. See if I can draw an actual straight line here. So something like that. It's probably going to go a little more on the up and up, but that should be kind of the idea of our line here. And I should be able to draw a pretty accurate one because I know the equation now. And then part E, the temperature is predicted to be 19.5 degrees Celsius. So estimate how many bottles of water should be stocked according to the regression line. And that's just saying, okay, I'm going to plug in 19.5 into my equation, once I have that regression line equation figured out, and I can figure out what my y value is. Okay, 132.275. Okay. And you're saying, so how many water bottles should be stocked? Well, I'm not going to have fractions of water bottles. So I want to have 133 water bottles stocked. Because if I have 132, I'll run out. So 133 would be good enough. That's like kind of where we use this information to figure it out. All right. Okay, sorry, that was kind of a long